Okay, here comes a set and drift problem, number 1 on page 37 of the set and drift portion of your student handbook. Whenever I do one of these problems, I like to, well, let's read the problem first. It says at 10:20 your position is latitude 41 degrees 11 minutes north by longitude 71 degrees 50 minutes west. You are on a course of 56 degrees per standard magnetic compass at 8 knots. 1 hour later, your position is 41 degrees 15.9 north by longitude 71 degrees 41.7 west. What was the set and the drift? So when I do one of these problems, I like to write a couple of things down. I like to write true and dr, or distance, okay? And I like to write end position, or EP, end position. So my true, okay, the true course, it says you're on a course of 56 degrees per standard magnetic compass. Can I plot in compass, or do I have to do something with that? The answer is you have to make the compass course, which is in magnetic, okay, or in compass, you have to make that true. So I'm going to true up the course of 85 degrees, or 56 degrees. So how do I do that? I do TVMDC, and the course is in compass, so I take 56 degrees, okay, and I work that up using my deviation table. Okay, I'm going from compass to true. So what do I do with those errors? I subtract any westerly error or errors, and I add any easterly errors. So if I've got a heading of 56 degrees, okay, 60 is pretty close, so that's 4 east. And what do I do if I have an easterly error? I have to add it. So 56 and 4 is 60. And then I have variation on this chart, which I get from the compass rose. We have the true north and the magnetic north, which are 15 degrees apart, and it's 15 degrees west. So the variation on this chart is 15 degrees west. So I will be subtracting that. Okay, so 60 minus 15 gives us a true course of 45 degrees. So I know my true is 45 degrees. Okay, my DR, my dead reckoning position, is how far I will travel, okay, given the time I was out there. So if I'm going at a speed of 8 knots for 1 hour, okay, how far will I travel? Well, that's pretty easy. I'll travel 8 miles. Okay, so my DR, or my distance, is 8 miles. That's how far I'll travel from my starting position. Okay, and then my ending position, which is 41 degrees 15.9 by 71 degrees 41.7. So that's my ending position. So now that I've got all that information, I'm going to go ahead and I'm going to go to the chart. So the first thing I'm going to do is I'm going to plot the starting point. So again, the starting point in this problem was 4111 by 7150. All right, 7150, that's pretty easy because it's already on the chart. Okay, so 7150 is right here. Okay, 7150, and 41, what was it, 4111, I think it was, 4111. So here's 4110, so 4111 is just up 1 mile. So I'm going to use this guy right here, okay, because I've got a pencil on that end. So I've got 1 mile, so if I come over here to 7150, I can mark my starting point pretty quick and accurately. So here's my starting point. Okay, this is where I'm starting from. Okay, and I'm on a true course of 45 degrees. So I'm going to find 45 degrees on the nearest compass rose. Okay, 45 degrees is right there. Let's see if I can get this. 45 degrees. Okay, and I walk that over to my starting point, which is awful close to where I am right now. And I just draw a long line in the direction that I'm going. From my starting point, I'm going 45 degrees. So this line is going 45 degrees. Okay, so that's my true course. That's the heading that I'm on. Now I'm going to take my distance. So distance, the speed I was traveling for 1 hour. So since I was only going for an hour and I was going at 8 nautical miles per hour, I'm going to mark 8 miles. So let's see if I get lucky here. I think these will open just about to 8. There's 8. Okay, so I'm going to go from my starting point right there, and I am going to go 8 miles, just right here. That's my DR. Okay, that's where I should be in an hour. Okay, now I want to plot my ending position, EP. Okay, ending position. So I've got 4115.9. Let's see an easy way to do this. 4115.9. There's 15, and there's 0.9. Okay, I'm not going to mark that just yet. All right, 4115.9 by 7141.7. So 41.7, I'm going to go over here. 41.7, looks like right about there. 41.7. Okay, so now that I know where that is, I'm going to make a mark. Okay, right there. And I'm going to make another mark right there. So here's where I ended up. So I ended up right here. I should have ended up over here. So what is that telling me? I'm supposed to be on the line, but the current is setting me in this direction. It's pushing me, setting me in this direction. Okay? So what is that direction? Well, let's find out what that direction is, because the question is, what is the set and the drift? So set is the direction that the current's going. I could draw that line, but I don't see any reason to do that. Okay, I'm going to actually do it from this here. Okay, because now I'm very close, I hardly have to move it. So the set is the direction the current's pushing me. So I should be on the line, so it's pushing me this way. So I'm going to read this side of the compass. So I'm just going to walk this over. Okay, I'll make a little mark just so I can see what that is. And that looks like that number is, I'm going to call that 141. Okay, so my set is 141. Okay, at what's the speed of the current? Okay, the speed of the current would be the distance, okay, from where I should be to where I am, divided by the time. Well, in this problem, the time was only 1 hour. Okay, so if I take this distance and I divide it by 1, it's going to be the same as the distance. So it's 1.1. So 1.1 divided by the time I was out there, 1 hour, is going to give me 1. So my answer is 141 at 1.1 knots. Okay, that's a set and drift problem. This is number 1 in the set and drift problem. Let's see if I have a choice close to 141 at 1.1 knots. There it is, 141. B, number 1 should be B. Your math should look just like that. It's not real complicated math. All we really did was took the compass course of 56 degrees. We made it true. Okay, we plotted it from the starting point. We just drew a long line in the direction that you're going. We marked the DR where we should be on that line, and then we found the ending position. Okay, there's our ending position. We plotted it on the chart. Then we took the direction that the current set us. Okay, it pushed us from the line where we should have been. Okay, down here. So we walked that over to the compass. We read that side of the compass, and then we measured the distance and divided by the time we were out there, which happened to be an hour, so it made it quite simple.